short little quiz, almost like how are you doing overall. Accuracy is defined as, what do you think? B? The smallest increment is called the precision. So it's not B. A. Yes. How close the value is to the true value, the target. Right? True value is like the target or the nominal, right? So A is the answer, yeah. Circle or put the letter down. An object is weighed on a balance and determined to weigh 0.05 grams. What's the precision of this balance? D, right? Because the precision lies on that second decimal place, so that's where we put the 1. Okay. So it's D. The wingspan span of a female red-tailed hawk is being monitored, and it's determined to be 130 centimeters. What is the precision and uncertainty of this measurement? This is a little unfair, in my opinion, this question. We wouldn't do that, but out of these options, you should have picked A, because the reason it says precision unknown is because technically this thing could be going up by tens, right? We don't know if it's like 10 centimeters at a time or if it's just 1 centimeter at a time. So based on the options you had, A is the one. Because of the 1 centimeter, right? None of the other ones have 1 centimeter. So A is the only one that would have applied. I won't do that to you on a test. Don't worry about that. Jeanette is measuring a piece of copper pipe. The true length is this. Using a tape measure marked in 0.1 centimeter increments, what's the most precise measurement she can record? So she can only go as close as to the nearest tenth here. Okay, so this would be 17.7 would be your correct answer here. This would be the correct answer. Because what you're assuming is that whatever you're using to measure is able to do this. Right? It goes up by 0.1 centimeter at a time. So where is this piece? 17.706 is so close to 17.7. Like you can't, like it would round to this. Okay? So C is your answer there. Yeah, I know it's annoying. What about this one? So there's different times recorded. If all the times are added together, how long would it take the team to complete 20-kilometer race? So you need to add up all these times. So if you do that, if you just go 19, 18, 17, and 21, you get 75 minutes. If you add up all the seconds, you get 73 seconds. And that's kind of weird, right? You can't have more than 60 seconds here. So what do? We take 60 off of this and add a minute to the other side. So it's 76 minutes and 13 seconds. Okay? However, how many did we add up? How many times? 4 times, right? They all have the same precision and uncertainty. What is the precision and the uncertainty for every single piece? It would be 1 second. Yeah, because these are your seconds here. That's the smallest unit, so it's to the nearest 1 second. So uncertainty is 0.5 of a second. Okay. So what would we do here? We would go plus or minus 4 times this. Okay. Yeah, exactly. 4 times 0.5, that's 2 seconds. Okay, plus or minus. So that's what should get added onto the end here to get marks. So what's going on here? I will give you 1 mark for having added the times together. I'll give you 1 mark for figuring out the precision and the uncertainty. And I'll give you another mark for combining the uncertainty, for actually having the two. So let's say you get your precision and uncertainty wrong. you lose this mark, but if I see you multiplying your uncertainty times 4 and adding it, you would still get the step for this particular mark here. So you could still get 2 out of 3 if you made a mistake on your... What about if you forgot to take off the 60? Half a mark off for that one today. Okay, because you're technically not wrong. Saying 75 minutes and 73 seconds, it'd just be weird, right? To give the time in more, like in more than 60 seconds for the second part, right? A doctor measures a dose of 2 milliliters. What is the precision uncertainty for this? Precision is 0.01 milliliters because it's the second decimal. Uncertainty is half of that. That's 0.005 of a milliliter. 1 mark for each. Which of the following is most precise? I'm gonna tell you smallest unit wins, right? Smallest unit is the first thing you want to check for. And then you want to check for most decimal places. If all of them have the same unit, then now you're looking for the smallest decimal place, or like the most decimal places. So that would be this one, right? Question, what if I threw in this one in the mix? That would be the most precise. Okay. So it doesn't matter what the actual value at the measurement, it matters how small the increment could be, and this instrument would have a very, very small increment. Okay. So this page is worth 10, I believe. Let me check. 1, 2, 3, and another 3, that's 6, 7, 8, 9, 10. So 10 marks for this page. Then we go to the back side. What is the length of the black bar, including the uncertainty? So you measure which one is it closest to. It will be 62 millimeters, correct? So here you have a choice actually. You can either say 62 millimeters. Yeah, that's the second option that I will do, 6.2. You could do millimeters because the smallest increment here are technically millimeters, right? Plus or minus, technically the precision is 1 millimeter. The uncertainty is 0.5 of a millimeter. So you could say that. You get full marks for this one. However, yes, if it's centimeters, if you want to state this in centimeters, then this is 6.2 centimeters, plus or minus. In this case, my precision is what? 1/10 of a centimeter, which is 0.1 of a centimeter. The uncertainty, therefore, is 0.05 of a centimeter. So if you want to state this in centimeters, be my guest, that's fine, as long as you're consistent with the units. Is it possible to have different units? It is possible. You just have to make sure you state the units. How many marks? 2 marks for this. 1 mark for the measurement, 1 mark for the uncertainty that's tagging along. Which of the following describes the concept of tolerance and measurement? A, the length of a gutter must be a minimum of 12 feet. Not yet. It has to talk about both extremes. So this one is not good. A drilled hole has to be big enough to fit a 5 millimeter dowel, but small enough that the dowel does not fall out. This one is definitely a good candidate so far. Combined weight of 6 items weighed separately will have a higher uncertainty. This is combined uncertainty concept, so that is a no-go. The average weight of a pumpkin is 2.5, also not what we want. That has nothing to do with tolerance. So B is your winner. B is the best answer there. The nominal value is defined as the target. Right? That's our target. Which of the following is another way of expressing this tolerance? Before you go commit, remember I always asked you to go max, min, tolerance, and nominal. Remember that? What's the max here? 0.7650. When it's stacked like that, the top number is your max. The bottom number is your min. Tolerance is found by subtracting these two. That is 0.01. 0.01 of an inch. So double marks like that is inches. One is feet. If you need a reminder. What's my nominal under these circumstances? Add and divide by 2. So 0.6. Sorry. It's very crowded. I know, my bad. But the nominal ends up being 0.76 inches. Okay, sure, you could do the zeros behind it if you want. Not a big deal. So which one does this fit? This one is definitely not it. It has nothing else, just a measurement that's not tolerance. So maybe you can like rule out. This one is telling us that the nominal is 0.77. That cannot be based on our findings. So that one is out. And the tolerance is what? Right? It doesn't match our tolerance, so out. So which one is it then? It's A, I think, yeah. Because if it's minus 0, that means that our minimum is 0.7550, which it is. And if it's plus 0.01, you are here. Right? This is our tolerance. This one right here corresponds to this format. Okay, that one right there. So this is the one. Why can't this not be it, folks? What needs to be in front of that tolerance normally? A half. Okay, so this one is also out for that reason. Okay, given the tolerance of a pipe, okay, state the tolerance in the other three formats. I'm going to ask you to do this one more time. This is my last go at tolerance. Okay, then you're on your own for tomorrow. Nominal. Do I know my nominal off of this? Absolutely. Yeah. Tolerance is technically 0.9, but I would always confirm with this method here. Half of 0.9 is 0.45. Okay, half of that. So I'm going to go 64.5 plus this. That would be, is that 64.95? Yeah. And then minus 64.05. There you go. So when you subtract this, you should get that. So this is your little inventory here before you go out and write it. So the max and min like this, you just grab these two numbers. Oh, why did I put a line there? 64.95 and this is 64.05. Okay? Make sure you have units. Is something wrong? You mean you can't read my writing? What's wrong with my writing? Is that better? I'm rushing. I shouldn't be rushing. Calm down. Settle down. Minimum is that 64.05 inches plus or minus. Ooh, I'm rushing. Plus tolerance. My tolerance is 0.9 of an inch, and this is minus 0 inches. The maximum is right there, 64.95 inches plus 0 minus the tolerance. So I use this template to help me rewrite it in all these formats there. All right. So so you get 1 mark for each correct rewriting. Let's say you make a mistake here. I would say half a mark for 1 mistake, 1 full mark deduction if you make more than 1 mistake here. Okay? And then we will honor these here. I guess you would lose a mark 2 out of 3 if you make 2 mistakes here. Okay? So 3 and 1, that's 4, 5, 6, 7, 8. So 8 marks for this back side. And 10 for the front. So we are at a total of 18. So cross out that 17 there. And just put out of 18.